So this is my unpacking of the SN74HC 595 chip, and that is a 8-bit shift register. And here I've got four SN74HC74s, which are dual D latches, which means that there are two D flip-flops on each chip, and that simulates 8 bits, which is what the 595 shift register does. So I've connected the Arduino data pin to the first D input of the first flip-flop. Then the Q of the first flip-flop goes to the D of the second. The Q of the second goes to the D of the third, etc. And I've also connected the clock pins together to synchronize the clocks. And that is how I've simulated the 595 shift register. And here I've just put in a counting code which makes the LEDs count. And as you can see, the LEDs are ghosting a little bit. They're flashing whenever data is sent through. And this is because there's no latch when you only use four of these chips to simulate a 595 shift register. So whenever data is sent through, all of the LEDs will flash on and off.
So this is my faucet diagram for the unpacked SN74HC595 shift register. So as you can see, the first Q output goes into the next D input, and then the second Q output goes into the third D input, and that repeats for 8 times, actually 7 times. And then there's LED going out of each of the Q outputs, and the clocks are all synchronized together. And by using 8 of these flip-flops, we can simulate a 8-bit shift register, which is the SN74HC595. And by connecting the Arduino data pin to here, the data of the first flip-flop, and by connecting the Arduino clock to any of the clock pins, which are connected together, this can be used as a 595 shift register. However, since we're only using 8 flip-flops, there is no latch.
So this is my Unpacked 595 shift register connected to an LED bar graph. So you can see the first 8 bits on the bar graph are being counted from 0 to 255. And there's still a little bit of ghosting going on here if you see it in real life, but on phone camera it doesn't really pick up. So here I've substituted the 595 shift register for the unpacked version on an LED matrix. So the output of the T-pit goes into the input of the first flip-flop, and I've connected the clock pins together. And the output of each of the flip-flops go into the respective input of the matrix. And the matrix is still ghosting a little bit, but I fixed it a lot by blanking this entire display after lighting up each column. This fixes some of the ghosting, but it's still lighting up a little bit. So here's another animation, the scrolling text. The ghosting actually looks like it's not really there in real life, but if you look through the phone camera, it looks like it's still kind of hard to see. So this is my attempt to connect the Unpacked 595 shift register to my long ISP, which is the Connect 4 on an LED matrix. So you can see I've got the buttons, the switch, and the 555. However, because I have to update every LED of the players individually, because one player has to be brighter than the other to distinguish them, that causes way too much ghosting. And as you can see, you can still see player 1, but you can't really tell where player 2 is. So this works, but like there's too much ghosting, so it doesn't work that well.